Morning, chemists. Today what we're going to do is we're going to put together some models of covalent compounds. And hopefully you're going to see how the shape of the models, you actually put them together, it's kind of what we think they look like three-dimensionally, that's going to match the dot diagrams that you have. You're going to draw a picture of it, you're going to draw a dot diagram. Then I'm going to show you structural formulas, which are pretty easy. All right, so what we're going to use is stick and ball models, and the balls are little wooden balls like this, and they have a certain number of holes drilled in them. For example, the yellow one is hydrogen. It's got one hole in it. The red ball is either oxygen or sulfur. It's got two holes drilled in it. Nitrogen has three holes drilled in it. That's the blue one. And the black one is carbon. It has four drills into it. And once you see how they're put together, I think that'll make sense. We also have some halogens. We have chlorine, which is green, has one hole drilled in it. So we also have a purple one, which is fluorine. All right, so we also have, you're going to put them together using two things, either sticks, those are for single bonds, or springs, these are for double or triple bonds. What can springs do that sticks can't do? All right, so they bend, and that's an important part of this. So we're going to start out with the simplest one possible. All right, we need, to make hydrogen, you need two yellow balls and one stick. And the rule is, once you're done, all the holes have to be filled here. So that one's filled, that one is filled. That's what hydrogen looks like. All right, if you want to pause this, draw a picture, that's what I would do. The second one is water. And water has an oxygen with two holes in it, two hydrogens, each with one hole in it. So again, when we get two sticks, you're going to fill the holes. So I'm going to attach one hydrogen to the oxygen. I'm going to attach the other hydrogen to oxygen. And this molecule right here, that's water. Now, what I'm going to do with this is I'm going to take this up and I'm going to show you guys how this actually matches what goes up here. So on your sheet, you're supposed to write a name. You're supposed to write water, and then I'm going to draw a picture of them. All right, so there's the picture. Hope you guys see how those look alike, like that. And then I'm going to draw a dot diagram. So here's oxygen in the middle. That's the oxygen. It's got 1, 2, 3, 4, whoops, 1, 2, 3, 4, 5, 6 dots. And then I'm going to put a hydrogen on here. There's a hydrogen. And there's a hydrogen. All right. What I'm hoping is that you guys can kind of see how those look alike, how you can imagine a dot diagram in a three-dimensional picture, all right? And here's something new. Every time you have a shared pair of electrons in a structural formula, you would write it as an H with a line showing the dot pair of the covalent bond. There's my oxygen. And there's the hydrogen. You see how those kind of look the same? There's HOH. Here's HOH. I just didn't bother. The structural formula doesn't show the unshared pairs. All right. The next one is methane. Methane needs one carbon with four holes in it. We need four sticks. So I'm going to put a stick in each one of the holes here, like this. And then you also get four hydrogens. So I'm going to put one hydrogen at the end of each stick. Now we're not going to worry about the name of this shape, but this shape of a molecule that looks like this is called a tetrahedral shape. Tetra still means four, and this thing is symmetrical all the way around it. So let's go up and let's draw a picture, and let's draw a dot diagram of structural formula for this one too. All right, methane, CH4. Now, how do you draw this thing up here? Well, let's try. I'm going to put my carbon in the middle. There's a hydrogen on top. There's a hydrogen off to the side. There's one kind of sticking out in front. And there's one kind of in the back there. So I hope that you guys can see how that kind of looks the same. Now, if I hold it in a different way, all right, I'm going to put the carbon in the middle. Let's draw a dot diagram. Carbon has 1, 2, 3, 4 dots. And then I'm going to put a hydrogen on each one of those. kind of square that up a little bit. There we go. So to me, that kind of looks like a cross. Well, how does that thing look like a cross? Well, if I hold it up so it looks like that, that kind of looks like a cross there, all right? Now for the structural formula, pretty easy. There are 4 bonds, so carbon with 1, 2, 3, 4 lines sticking out of it. Hydrogen, 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 hydrogen. That's the structural formula for methane. All right, the next atom that we're going to draw is chlorine, Cl2. So I need 2 green balls, each with 1 hole in it. And so I have everything filled up. It's pretty simple diatomic compound, molecule like this, all right? Looks similar to hydrogen, except you're going to have more dots when you draw your dot diagram for it. All right, ammonia is NH3. Ammonia has 3 holes in it, so I'm going to fill the 3 holes here. And then you're going to have 3 hydrogens on the end of each one of those. So there's ammonia. Okay. The next one is 2 atoms. It's another binary compound, only 2 atoms. It's got a hydrogen, it's got a fluorine, and I only need 1 stick. And since each one has 1 hole in it, that's HF, or hydrogen monofluoride. Okay, dot diagram. You're going to have more dots around this one than this one. All right. The next one is ethine. Ethine is kind of tricky looking. I need 2 carbons. Each carbon has 4 holes in it. I need 3 springs, and remember, springs can bend. I need 2 hydrogens, and I need 2 sticks. All right, so if you were listening to me before, you heard me say that the springs are for either double or triple bonds. Hydrogen can't form a double or triple bond, so I'm going to put a stick in each one of those. Now, if I bonded those 2 together, there'd be nothing for the carbons to bond to. So that means the hydrogens must have to bond. Each one is going to bond to a carbon. All right. Now, I have 3 holes left here, I have 3 holes left here, and I have 3 springs. So I'm going to put the springs in one of these carbons so it looks like this. And remember, the springs can bend. So I'm going to put that one in there like that, and that one in there like that, and all of a sudden one of my springs came out here. So I need to fix that. So this molecule right here is ethine, C2H2, and it has a triple bond in it. When you see those 3 springs, it has a triple bond. All right, so let's go draw a picture of this, and let's draw a dot diagram, and let's draw a structural formula. All right, so that's what I need to draw. So I'm going to draw a hydrogen. Whoops. There's a carbon. There's a carbon. And there's a hydrogen. And I'm going to draw 3 springs between it. And that's my artist's rendition of a spring. All right. Hard to tell the difference between the model and the drawing, isn't it? They're almost identical. Okay, so now let's draw a dot diagram. Each one of these springs or sticks represents a pair of electrons. So I'm going to go hydrogen, carbon, carbon, hydrogen for my dot diagram. I know I'm going to have, because I have stick, I'm going to have 1 pair of electrons here. I'm going to have 1 pair of electrons here. And there's my triple bond. I need to have 3 pairs there. So 1, 2, 3, 4, 5, 6. All right, so there's the dot diagram for that model. All right, let's draw a structural formula for this. H dash C, 3 dashes, C dash H, single bond, triple bond, single bond. All right, the next one we're going to do is dichloromethane. Dichloro, 2 chlorines. Methane is that carbon with the hydrogens on it, and I need 4 sticks. All right, so I'm going to start with the carbon in the middle. Carbon gets all 4 sticks, and it doesn't matter where I put them. 2 of the hydrogens go on 2 of the sticks. 1 of the chlorine goes on the other. And there's that tetrahedral shape again. 2 chlorines, 2 hydrogens, dichloromethane. All right, so the next one I'm going to draw is nitrogen gas, N2. I need 2 blue balls. I need 3 springs, and springs can bend. So each nitrogen has 3 holes in it. So that means I'm going to put the springs in each one of the 3 holes for the nitrogen. And when I put it all together, that's what nitrogen looks like. Obviously, there's a triple bond there. All right, so since you've already seen a triple bond, I'll let you guys work on that one on your own. All right, the next one that we have is carbon dioxide. And carbon, 1 carbon, dioxide, 2 oxygens, means I need 1 black one, 2 red ones, and in this case I need 4 springs, no sticks. And the springs are for double and triple bonds, I told you. So here's what we're going to do. Since the carbon has 4 holes in it, I'm going to put all 4 springs in the carbon to start with. And then I'm going to take 2 of the springs that are already in the carbon and attach them to an oxygen. I'm going to do the same thing over here on the opposite side. So that molecule right there, that's the carbon dioxide. I have a double bond. I have a double bond. Whoops. All right, there's my carbon dioxide. Carbon in the middle, an oxygen on each end, and I have 2 double bonds. So let's go draw that one. All right, carbon dioxide is CO2. We had the carbon in the middle. We had an oxygen on this side, we had an oxygen on this side. And there were 2 springs between it. So it looks kind of like that. Again, almost an exact copy. The picture and the model are actually hard to tell the difference between. There's so much alike. All right, so now let's draw a dot diagram. Well, I got carbon in the middle. So I put carbon in the middle, and I know the carbon is going to make 2 double bonds. That means it's 2 electrons, or it's going to have 2 electrons on each side, and I'm going to have an oxygen on each side. 1, 2, 3, 4, 5, 6 dots. Oxygen on this side with a double bond. Whoops. Oxygen on this side with a double bond. 1, 2, 3, 4, 5, 6. All right, so again, let's put the model up here. Carbon in the middle, those 2 dots. I mean, the X and the dot right here, there's a double bond, there's a double bond. You can see that with the springs, right? And when I draw my structural formula, carbon in the middle, double bond on this side, double bond on this side, attached to an oxygen, attached to an oxygen. So that's the structural formula for carbon dioxide. All right, methanol. Methanol is an alcohol, it's wood alcohol. It has 1 carbon, and it has 5 sticks. So I'm going to take 4 sticks and put it in the carbon. And it has 4 hydrogens. So if I take 4 hydrogens and I put it in here, like this, but I'm also supposed to have an oxygen. There's no place to put an oxygen here. I also get another stick for this. So one of these sticks has to go in here. So what I'm going to do is I'm going to take that hydrogen off, put it there, and now the hydrogen goes on like that. So there's the methanol. Methanol is wood alcohol, right? 1 carbon in the middle, 1, 2, 3, 4 hydrogens, there's the oxygen, and the oxygen's between the carbon and the hydrogen. All right, that one's going to be a challenge, but I think you can do it. All right, hydrogen peroxide. Hydrogen peroxide is 2 hydrogens, 2 oxygens, and 4 sticks. And so each hydrogen has to have a single bond, so I'm going to put a stick in each hydrogen like this. Oxygen has 2 holes in it, so I'm going to put one there and one in that one. And now I think I said earlier that you needed 4 sticks. No, you only need 3 sticks. So that means I'm going to put a single bond between the 2 hydrogens like this. This is hydrogen peroxide. This is the stuff they use to clean out cuts. It's a disinfectant, slightly acidic, so it might burn a little bit when you put it on there. And sometimes I call this the Harry Potter molecule because it looks like the zigzag lightning bolt. All right, oxygen. Oxygen should be no challenge to you guys now because you guys know about springs. All right, we need 2 red ones, 2 springs. Well, each red one has a hole in it. So there's oxygen. You've drawn this before with the dot diagram. That's got the double bond in it. And the last one that we're going to do looks an awful lot like one we've already done. H2S. H2S, the red ones can either be oxygen or they can be sulfur. They both have 2 holes in it. So there's the model for H2S, or dihydrogen monosulfide. All right, so go ahead and back and look at these, pause them if you need to, draw the picture, do the dot diagrams, do the structural formulas. I already showed you 4 of them. I think you can do the other ones.